A ball is projected vertically upwards at 16 meters per second from a height of 2 meters above the ground. We want to find the speed with which the ball hits the floor, which is at ground level. A clear diagram can help. The ball is projected from 2 meters above ground level. It's projected upwards at 16 meters per second. It will go up and then fall back down to hit the ground. We want to know v. Throughout the motion, the acceleration due to gravity is 9.8 meters per second squared. We collect our information in the usual way using SUVAT. The ball hits the ground 2 meters below its projection level. So if we take an upward direction as positive, since all of these things are vectors, S has to be minus 2 meters, the minus indicating below the original level. The initial velocity is 16 meters per second. The final velocity we're trying to find, and the acceleration being downwards, needs to be minus 9.8 meters per second squared, since we took the velocity as upwards. These quantities are related by v squared is u squared plus 2as. Substituting in, v squared is 16 squared plus 2 times minus 9.8 times minus 2. So v squared is equal to 295.2, and square rooting gives us that v is equal to 17.2 meters per second, correct to 3 significant figures. This makes sense, since the object has fallen further than it was thrown upwards, so we would expect this to be faster than the speed of projection. For the same ball, we want to find the greatest height reached. So our ball is projected upwards at 16 meters per second. When it reaches its greatest height, the ball will have a velocity of 0. If you think about this, if the velocity is positive, the ball is travelling upwards. If it's negative, it's travelling downwards. So at its greatest height, the speed must be 0. Throughout the motion, the gravitational acceleration of 9.8 meters per second squared is acting. We want to know the height h. We collect our information in the usual way with SUVAT. We want to find the height. The initial velocity is 16 meters per second. The final velocity is 0 meters per second, and the acceleration is minus 9.8 meters per second squared, as it acts in the opposite direction to the velocity, and we've taken the velocity to be positive. These are related by v squared is u squared plus 2as. So 0 squared is 16 squared plus 2 times minus 9.8 times the height. So 0 squared is 16 squared, take away 19.6 h, and then h is equal to 16 squared divided by 19.6, which is 13.1 meters, correct to 3 significant figures. This is the height above the point of projection. For the height above the ground, since the object was projected from 2 meters above the ground, the object would be 15.1 meters above the ground. We now want to find the time for which the ball is more than 4 meters above the ground. Remember that the ball is projected from 2 meters above the ground, and it's projected upwards at a speed of 16 meters per second. It will go up and come back down. Throughout the motion, the acceleration due to gravity is 9.8 meters per second squared. It's projected from a height of 2 meters above the ground, so to be 4 meters above the ground, we need to consider when it's 2 meters above the height of projection. Clearly, it will go through this height at 2 times t1 and t2, where t2 is the time on the way down and t1 is the time on the way up. The difference between these two times will be the time for which the object is above 2 meters from its point of projection, or 4 meters from the ground. We collect our information using SUVAT in the normal way. This is 2 meters. The initial velocity is 16 meters per second. We're not interested in final velocity. The acceleration is minus 9.8 meters per second squared in the opposite direction to the velocity, therefore negative. And we're after the time. These quantities are related by s equals ut plus a half at squared. So 2 is equal to 16t. Half of a is minus 4.9 t squared. Rearranging, this gives us 4.9 t squared. Take away 16t plus 2 equals 0. We need to solve this quadratic equation, and we can do so using the formula. So t is 16 plus or minus the square root of minus 16 squared, take away 4 times 4.9 times 2, all divided by 2 times 4.9. This is 16 plus or minus the square root of 216.8, all divided by 9.8, and calculating this gives 2 times. We get 3.135 and 0.130. The difference between these two times is the time that we're above 2 meters, So subtracting, we get 3.01 seconds to three significant figures, and this represents the length of time for which we're 4 meters above the ground or 2 meters above the height of projection.